Good morning, guys.
Good morning, ma'am, and good morning, class.
Okay, Adna, you can start the class because okay, it's ready the class.
Okay, welcome to today's class. We will try to cover six topics today in chemistry. The first one is chemical reactions and combinations. The second one is adding it all up. The third one is hot or cold. The next one is a balancing act. And another one is chemical solutions. And after chemical solutions, we will talk about acids, bases, and other anomalies. So let's start from chemical reactions and combinations. A very, very interesting topic and a very useful topic. It is required in industrial chemistry. It is required in engineering and biology, everywhere where people are dealing with science and people are creating something. We need chemical reactions and we need to know about the combinations by which the chemical reactions they occur. So in the chemical reactions and combinations, the chemical reactions involve the transformation of substances into new substances with different properties. The key components of a chemical reaction are reactants and products. For example, we have a reactant A and we have another reactant B. They react together and they create AB. So this is how the chemical reaction goes. On the left-hand side, we have reactants. So as you can see here on the left-hand side of the arrow, we have A plus B, and they are called reactants. And on the right-hand side, we have AB, and these are called products. So you can see here that A and B has been converted into a new product AB. So this product will have different properties than the individual reactants A and B. So the arrow is used to show the direction of the reaction. So we can see that the direction of this reaction is on the right hand side. This reaction is taking place from the left hand side towards the right hand side. Sometimes we have reversible reactions, and we use a double arrow which indicates that the products can also react with each other, or we can say that the products can decompose and they can change back to the reactants. So this is a simple example of how we should represent chemical reactions and how we normally represent chemical reactions. Chemical reactions and combinations, there are several types of chemical reactions, including synthesis, decomposition, combustion, and displacement reactions. Each type has its own characteristics and chemical equations. So what is synthesis? We are trying to synthesize something. We are trying to make something. So whenever we try to make something, we use synthesis. We call that reaction a synthesis reaction in which something is being created. Decomposition reaction is where one reactant splits up into different compounds or different molecules. Combustion is burning. When something burns in the presence of air, we call that reaction a combustion reaction. And we have displacement reactions where one atom is replaced by the other. So we will see the examples of these reactions shortly. So each type has its own characteristics and chemical equations. So the four main types of chemical reactions that we just studied, in the first one is synthesis. So you can see here we have on the left hand side, we have two reactants, A and B. And when they react with each other, when they react, we will have to give them a certain temperature and the reaction conditions, and sometimes we can add a catalyst as well. So these two reactants, they combine together and they form a new substance, a new molecule, a new compound, and here it is represented by AB. So decomposition it is the opposite of synthesis. So now we have AB here on the left-hand side as a reactant. And what happens in the decomposition reaction, as I just explained on the previous slide, that this molecule AB, it will split into A and B. So this is how the decomposition reaction, it works. So now we have a single replacement reaction. We have the two types of replacement or displacement reactions. We have a single replacement and we have a double replacement. In a single replacement, AB reacts with C, and you can see here that this B has been shuffled with C. So instead of AB here on the product side, we have AC, and now B has been separated. It is shown separately here as an individual compound. So when AB, it reacts with CD in double displacement reaction, we get AC and BD. So this is how this reaction works. This is a double displacement reaction. You can see that B has been replaced with C, and here D has been replaced with B. So here we have AB. So instead of AB, here we have AC, and on the left-hand side here we have CD, and instead of CD we have B and D here. So now we are moving towards the second topic, and that is adding it all up. So adding it all up basically means that we are dealing with stoichiometry, we are dealing with combinations. As we can see here that we have a balanced chemical equation. This is methane, CH4. It is reacting with two molecules of oxygen, which are represented here in red. And these reactants are reacting together, and they are converting it to carbon dioxide, CO2, and we are getting two water molecules. So in this reaction, we can see here that we have a balanced chemical equation. CH4, we have one carbon on the left-hand side, we have one carbon on the right-hand side. We have 4 oxygen atoms here, we have 4 oxygens here, 2 are here, and the other 2 are here. So 2 plus 2, 4. So this is a balanced chemical equation. We have 4 hydrogens here, and we have 4 hydrogens here. 2 times 2, we get 4. So 4 hydrogens here. So this is a balanced chemical equation. So we can say that when one molecule of methane, it reacts with 2 molecules of oxygen, it is producing 1 molecule of carbon dioxide, and it is producing 2 molecules of water. So these are stoichiometrically equivalent. These are all equal ratios, and they will change proportionally. For example, if instead of 1 mole or 1 molecule of methane, if I change it to 2, so what will happen to the concentration of oxygen? It will change to 4. It will double, right? So similarly, carbon dioxide will also double. So this will also become 2, and here this will become 4, right? So 2 will be converted into 4, and 1 will be converted into 2. So this is how we can calculate whatever we want to calculate by knowing the reactants, or by knowing the balanced chemical equations, or the ratios that are used in the balanced chemical equation. So I hope this point is clear. We just need to cross multiply, and we get our calculation, we get the answer. So here I have added some of the methods to convert one thing into the other. So if we have number of moles, or they can be converted into grams. How do we convert moles into grams? We multiply by molar mass. We calculate the molar mass of the compound, of the atom, or the molecule, whatever we are trying to convert, and we multiply it with, we times it with the molar mass. And if the mass is given in grams, so we convert it into moles by dividing it by the molar mass. So these are simple calculations. And if the reactants, the concentration of the reactants is given in liters, and we have to convert it into moles, we divide by 22.4 liters at standard temperature and pressure. This is STP. and these are called standard temperature and pressure. And if we have number of moles and if we are trying to convert it into liters, how do we do that? We times it by 22.4 liters. This is a constant that we use, or a conversion, converting ratio. So if we have particles, what do we mean by particles? For example, we have a number of atoms. So we are trying to convert the number of atoms into moles. We divide it by the Avogadro's number, which is 6.02 times 10 raised to the power 23. And if we have number of moles and if we are trying to convert it into particles, we times it by with 6.02 times 10 raised to the power 23, which is the Avogadro's number. So this is how this is the calculation that we can use on both on the left hand side and the right hand side to measure or to guess or to calculate the number of reactants that will be formed. So this is how the adding it all up is used. So these are all the calculations that you will have to do. Another thing in adding it all up, which is a very important point, is the law of conservation of mass or law of conservation of matter, which says that technically whenever a chemical reaction takes place, whenever the reactants are converted into products, the mass is retained. The mass, we don't lose mass or we don't lose matter. It is not that the matter will be converted into energy. Yes, sometimes it can be converted into energy, but we need a lot of energy in order to convert matter into energy. So according to the law of conservation of matter, matter is neither created nor destroyed. So we must have the same number and kind of atoms after the chemical change as were present before the chemical change. So this balance in nature is very important. And like on the planet Earth, the matter which was created millions and millions of years ago or billions of years ago, it is pretty much the same at this point. So law of conservation of mass or law of conservation of matter. If you look here, we have methane, CH4. And what is the molecular mass of methane? It's 16 grams. How do we calculate that? We add the atomic mass of carbon, which is 12, and we times it with 4 because we have 4 hydrogens, and the atomic mass of hydrogen is 4. So 12 plus 4, we get 16. So we have 16 grams of methane here, and we have 64 grams of oxygen. And if we add these two together, we get 80 grams. So we have 80 grams of mass, we have 80 grams of matter on the left-hand side. And after the chemical reaction, we can see that the products, when the products, when we have the products, these two products have been converted into a carbon dioxide and water. So if you add the total mass of the right-hand side, you will get 80 grams. So this is very exciting, and this is a law. And this is how the nature works. In chemical reactions, matter does not normally change into energy, and matter stays here all the time. So this was adding it all up. So now we are moving towards the third topic, which is hot or cold. So whenever we think of something like hot or cold, so there in chemistry, we have different terminology that we use for hot or cold. We use exothermic and endothermic reactions. So what are exothermic and endothermic reactions? Facundo, do you have any idea? I hope you are listening. Is my voice clear? Can you tell me what is exothermic reaction?
I don't know.
Okay, so pay attention, I'm about to explain. So any reaction where heat is released, exothermic reaction is any chemical reaction where heat is released. Is it clear? Can you repeat after me?
An exothermic reaction is a reaction that the heat
Yes,
is released.
excellent. Yes, where heat is produced, right?
Yes.
Any chemical reaction where heat is produced, and endothermic reaction is the completely opposite of exothermic reactions. So what will happen in the endothermic reaction?
The and it's released with the cold.
We say that heat will be absorbed. Okay. Yeah, so in exothermic reaction, heat is released, and in endothermic reactions, the heat will be absorbed. Okay, so
Okay.
yes, so thank you. So let's move on. So exothermic reactions, as the name indicates, exo. Okay, it means outside. The heat is being released. Exothermic reactions are those reactions in which the heat is released, and endothermic reactions are those reactions in which the heat is absorbed. So these are the two types of reactions that we mostly study in chemistry. So you can see here, this is the endothermic reaction. And if I ask you to give me the example of the endothermic reaction, so what will be the example of an endothermic reaction? You guys may have seen the ice melting, right? So the melting of ice is a very good example of the endothermic reaction. So what is happening? The heat is being absorbed by ice. So for example, you go to your fridge, you want to drink cold water, you take ice cube and you put it in your glass. And after some time, the ice cube will disappear, the ice cube will melt, right? So how is that the ice cube was changed into a liquid by absorbing heat. So the endothermic reaction is cooler than surroundings. And you can see here in this picture on the right hand side, the exothermic reaction is hotter than surroundings. And here, if you look at the direction of the arrows, the heat is being released, right? So energy is conserved in chemical reactions. The total energy of the system is the same before and after a reaction. So if we look at the energy profile diagrams of the endothermic and exothermic reactions, so these diagrams are very important. Sometimes they will give you these diagrams in your exam, and they will they will hide the labeling, right? They will hide this portion, they will hide this, and they will just ask you that by looking at the graph, how would you interpret the exothermic or endothermic reaction? They will give you this picture and they will ask you that tell me whether this graph represents the exothermic or endothermic reaction, right? So in order to identify, in order to know that which is which, you need to see that reactants in an exothermic reaction, the reactants are higher in energy and the products are lower in energy. So this is very important point in order to remember this, that in exothermic reaction, the reactants will always be higher in energy as compared to the products. And in the endothermic reactions, the products will be higher in energy as compared to the reactants. So if you can see here, the reactants, they are lower in energy, and the products, they are higher in energy. And this is the activation energy. Activation energy is the amount of energy, the minimum amount of energy required in order for the reaction to happen, right? So if the particles are colliding and they are below this energy threshold, the reaction will not take place. So I hope you may have copied the diagrams with you on your notebook and you have noted down the points so that you guys can revise, and do not forget this. This is a very, very important point. So we have a comparison here, that endothermic reaction versus exothermic reactions. Sometimes you will see a question on your exam that will say that differentiate between endothermic and exothermic reactions. So you will have to write 4 or 5 points, and normally the question like the total marks of the question can be 5. So the first difference is that endothermic reactions are chemical reactions that absorb heat energy from the surroundings, and the exothermic reactions are chemical reactions that release heat to the surrounding. The second point can be that temperature decreases with progression of the reaction, and in exothermic reaction, temperature increases with progression of the reaction. So the more the reaction takes place, the more heat it will produce. Enthalpy of reactants is lower than that of the products that we just discussed with the help of the diagram, and enthalpy of reactants is higher than that of the products in exothermic reaction. So change in enthalpy, which is denoted by delta H, is a positive value. Change in enthalpy, delta H, is a negative value for exothermic reactions. So if this value, delta H, is negative, you can say that the reaction is exothermic. And if this value, delta H, is positive, so just by looking at the positive value, you can confidently say that the reaction is endothermic. So we have a fifth point here. Energy should be given to the system. For endothermic reactions, we give the energy to the system. And for the exothermic reactions, the energy is released from the system. So this is how we differentiate between endothermic and exothermic reactions. So this was about hot and cold. We are moving towards our next topic, which is a balancing act. So in our last class, we also discussed this, but here we can revise, and it is a difficult topic. So the more you guys practice, the more you guys will be able to learn it quickly and properly. So what is a balancing act? It is related to a balanced chemical equation. A balanced chemical equation is an equation for a chemical reaction in which the number of atoms for each element in the reaction and the total change, or the total charge is the same for both the reactants and the products. It means that then the quantity of charge on the left-hand side should be equal to the quantity of charge on the right-hand side. In other words, the mass and the charge are balanced on both sides of the reaction. So how to balance a chemical reaction? These 3 points are very important, and we usually use these 3 points to balance many chemical equations, and these points can be applied to most of the chemical reactions. So the first one is count each type of atom in reactants and products. That you have to count that how many atoms of a particular atom do we have on the reactant side or on the product side, right? So place coefficients as needed in front of the symbols or formulas to increase the number of atoms or molecules of the substances, right? So repeat steps 1 and 2 until the equation is balanced. So it is a trial and error method. You will not be able to solve it most of the times, but just in one step, you will have to we call this a trial and error method. You will try, and then the number of other atoms will be changed, and then you will have to try again, and eventually you will reach a balanced chemical equation. The number of atoms will be balanced on the left-hand side and on the right-hand side. So this equation, it is a very important equation. It is a little bit complex, but if you practice this one, I'm sure you would be able to solve any chemical equation that is given to you in your exam. So if you look here, we have C3H8, this is propane. Why do we call this a propane? That we have 3 carbons, and it is reacting with oxygen, and it is producing water and carbon dioxide. So if you look here, how many carbon atoms do we have on the left-hand side of this arrow? 3, right? And if you look here on the right-hand side, how many carbon atoms do we have? We have only 1. this 2 does not represent carbon, it is representing this oxygen, right? So, and if we calculate the number of hydrogens on the left hand side, we can see here that we have 8 hydrogens on the left hand side, and we have 2 hydrogens on the right hand side. So there is a difference between the number of hydrogen atoms as well. And if we look here at the number of oxygens, we have 3 oxygens here, 2 are here with carbon, and 1 is here with oxygen. So 2 plus 1, 3. And how many oxygens do we have here? 2, right? So on this slide, we can see that we have separately written a CHO, C carbon atoms, we have 3, we have hydrogens, we have 8, oxygens 2, on this side 1, 2, and 3. So how will we start balancing this? We can start from changing the number of hydrogens and oxygens first. So we have 8 hydrogens on the left hand side, we have 2 hydrogens on the right hand side, we have 2 oxygens on the left hand side, and we have 3 oxygens on the right hand side. So you see here we have 3 carbons here, we have 1 carbon here, so we will put 3 here as a coefficient so that we can balance the number of carbons. So you can see here that we have added 3 with carbon dioxide. So by adding 3 here, we can see that the number of the oxygen atoms has been changed from 3 to 7. Okay, now here you can see that if we put 4 here, so the number of hydrogens will change from 2 to I think there is some background noise. Give me a minute so that I can alert them so that they can stop making this noise. So we will continue in 1 minute. Okay, sorry for the interruption. Okay, so now we have oxygens. We have 10 oxygens here. And if we move further, so now we can see here that by adding 5 with oxygen, the total number of oxygens have been balanced. We have 10 oxygens on the left-hand side, and we have 10 oxygens on the right-hand side. So the number of oxygens have been balanced. So the number of oxygens are also balanced, and the number of carbon atoms are also balanced. So if you count here, we have 3 carbon atoms here, we have 3 carbon atoms here, that's why we have written here 3, and we have 8 hydrogens on the left hand side, we can see here 8, and 8 oxygens on the right hand side, 4 times 2, we get 8. And we have 10 oxygens on the left hand side, 5 times 2, we get 10. And on the right hand side, we have 10 oxygen atoms, 3 times 2, 6, and 4, 10. So now our equation has been balanced. We have the same number of atoms on the left-hand side and on the right-hand side. So this was the balancing act. Now we are moving towards the chemical solutions. So what are chemical solutions? Chemical solutions are basically a mixture of solute and solvent. Solutions are mixtures, a homogeneous mixture. We say that solutions are the kind of mixtures that have uniform properties. So in chemistry, a solution is a special type of homogeneous mixture composed of 2 or more substances. In a mixture or in a solution, we can have more than 2 substances. Remember this. In such a mixture, a solution is a substance dissolved in another substance known as a solvent. So whenever we add a solute into a solvent, we get solution. And remember this, that solute will be in a lower quantity, in a smaller quantity, and a solvent will be in a greater quantity. So they play a crucial role in industries such as pharmaceuticals, environmental science, chemistry, and food production. So this topic is very important industrially. Pharmaceuticals, what do we mean by pharmaceuticals? And these are the companies that prepare, that manufacture drugs that are used by many people when we get sick. We can like aspirin when we get a headache, or paracetamol when our body is aching, right? Antibiotics that when we get infections, or vaccines. So solutions are very important. So environmental science solutions are created. In chemistry, different types of solutions are created, and for food production, we need a better understanding of solutions, of chemical solutions. So a solution is a homogeneous mixture where one or more substances called solutes are uniformly dispersed in a solvent. So how do we make a solution? We add solute into a solvent, right? So the solvent is the component that dissolves the solute, resulting in a homogeneous mixture. Facundo, I have a question for you. For example, if I am mixing sugar in water, what will be our solute and solvent?
Um, the 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 solute is the sugar.
Excellent. Yes, very good. That's right answer. So solute is sugar and solvent is water, right? So solute will always be in a smaller quantity, and solvent will be in a larger quantity. Thank you very much. Excellent. So the solvent is a component that dissolves the solute, resulting in a homogeneous mixture. So example, we have water is a common solvent. Water can dissolve many things. We can add sugar in it. We can add spices in it. We can add salt in it. So, and solutes such as salt or sugar can be dissolved in water to form solutions. So if you look here, so this is water, solvent, and we have our solute here. This can be sugar, this can be salt, or anything in a smaller quantity which water can dissolve. And when these two substances are mixed together, we get solution. So this is our solution here, and this is a homogeneous mixture. Why do we call this a homogeneous mixture? That is because all the atoms, they are uniformly arranged, and they are separated in a proper manner, right? So now we have different types of chemical solutions. This slide is particularly informative and interesting. So if you guys pay attention to this, you can learn a lot from this slide. So solutions can have different types. It is not just that you add sugar into the water and you can say that okay, I've made a solution. Gas and gas, when we mix gases together, we can also call that a solution, right? So the type of solution, gas in gas. So where a solute is also a gas and a solvent is also a gas. So this is a very very interesting information. Please pay attention. Solutions where gases are uniformly mixed with other gases. The most common example of this type of solution where gas is dissolved in another gas, that is air, the air that we are breathing, right? So we have different types of gases. They are mixed together in air and they are uniformly arranged, consisting of approximately 78% nitrogen, 21% oxygen, and small amounts of other gases. So here, oxygen is solute, Why? Because it is in a smaller quantity. And nitrogen is solvent because it is in a greater quantity. 78% of the air is nitrogen, and just 21% of the oxygen is present, of oxygen is present, 21%, which is solute, right? So this was the one example of a solution in which a gas is also a solute, and a solvent is also a gas. So the next explanation, or the next type of chemical solution that we have, is gas in liquid. So where a solute or solvent can be a gas, and a solute or solvent can be a liquid. Solutions where gases dissolve in liquids, carbonated beverages like soda, like for example Coke or Sprite. So what happens when you drink Coke? So if you shake it, if you shake the bottle, so you will see that bubbles are emerging on the top of the bottle. So we can clearly say that the gas has been dissolved in your soda drink. Have carbon dioxide gas dissolved in water, right? So this is also a solution, creating a fizzy drink with lots of bubbles. Liquid in liquid. So we have another type of solution where when we mix two liquids, we make a solution. So solutions where liquids are mixed together, alcoholic beverages like vodka are examples where ethanol is dissolved in water to create a homogeneous mixture. So this is the pie chart for the air, and you can see here that we have 78% nitrogen, and we will call this a solvent. Why? Because this is in a greater quantity. And oxygen and other gases, they are solutes because they are in smaller quantities. So oxygen is 21%, carbon dioxide is 0.4%, and other gases, which are noble gases, they are like argon, they are 0.96%, or if we round it up, we will end up with 1 or 1% are noble gases. So this is the example of the solution where gases are dissolved in gases. So another type of solutions are, we have solid in liquid solutions where solid solutes are dissolved in liquid solvents like salt water, right? Or like a cup of tea, or your cup of coffee, when you add sugar in it. So where sodium chloride is dissolved in water. Seawater is also the example of this type of solution. So dissolved in water is a well-known example. Solid in solid. Okay, so this one is interesting. So solutions where solid solutes are uniformly dispersed within solid solvents. For example, brass, an alloy of copper and zinc is an example of a solid solution. Here in this type of solution, the solute is also solid, and the solvent is also solid. And we call this, and the example is brass. So this was about chemical solutions. So and now we can represent chemical solutions in terms of concentration of solutions. Concentration of solutions. What do we mean by concentration? Concentration is whenever we are trying to quantify something, right? For example, when we say that how much amount do we have in a glass of water, we can say that I have added 1 tablespoon of sugar, or we can say that I have added 10 grams of sugar into 1 glass of water. So this is what we mean by concentration. We quantify, we measure the quantity of the solute and solvent we are mixing together. So concentration refers to the amount of solute dissolved in a given amount of solvent. And the unit for the concentration is molarity. This is a very, very important concept regarding solutions, regarding chemistry. You will see this most of the times on your exam. So you will have to remember this. You need lots of practice for this definition. So molarity is a common unit of concentration representing the number of moles of solute dissolved in 1 liter of a solvent. So this is how we define molarity. Here in the bracket, I have written mole per liter or more per liter. Okay, so how many moles of solute do we have in a liter? So a percentage, so what is a percentage? Percentage is another unit that is used for concentration and for the concentration of solutions. So concentration is another commonly used unit expressing the proportion of solute in the total solution. So these are the units that we use to tell others that I have added this much of solute in this much of solvent. So what are the applications of solutions? Pharmaceutical industry, solutions are used for medicine formulations, intravenous solutions, when someone gets an injection or when someone gets a drip, we call that. So like the vaccine, right? So for the coronavirus, during the coronavirus pandemic, we are still in the coronavirus pandemic. You guys may have received vaccines. So what was basically that vaccine? It was a solution and a way in which the medicine, it was dissolved in a solvent, and then it was injected in your body to fight off the coronavirus or to give you the immunity. And drug delivery systems. Environmental sciences, solutions are utilized in water treatment. We purify water with different types of solutions. Pollution control and environmental analysis in chemistry. Solutions are essential for laboratory experiments, chemical reactions, and analytical techniques. In food industry, solutions are involved in food and beverages production, flavoring, and preservation processes. So now we are finally coming towards the last topic of this presentation, of this class. We have acids, bases, and other anomalies. So what are acids? Acids are sour substances. They can burn. You should not touch them. Like we have strong acids and we have weak acids. What are bases? These are slippery, bitter tastes, bitter tasting compounds, and other anomalies. By other anomalies, we mean salts. So if we define acids, we can safely say that an acid is defined as a substance whose water solution tastes sour, turns a blue litmus red, and neutralizes base. What is base? Base is a substance. A substance is called base if its aqueous solution tastes bitter. What do we mean by aqueous solution? This is an important term here. So by aqueous solution, we mean that any solution that contains water as a solvent, and that is called an aqueous solution. So if its aqueous solution tastes bitter, turns a red litmus paper blue, and neutralizes acids, we call that a base. This is a general definition of base. And what is a salt? A salt is a neutral substance whose aqueous solution does not affect the litmus paper. So these were the basic definitions of the concepts, acids, and bases, and salts. So you need to remember this. These are often asked in your exams. So now we are going into detail. We are studying about acids. So what are acids? Substances that release hydrogen ions, which are dissolved in water. So whenever an acid is dissolved in water, it will give you a hydrogen ion, or we can call it a proton. So this is a chemical definition of what the acids. In the previous slide, we discussed a more generalized definition, but now we are defining acids in terms of chemistry. Examples of acids such as hydrochloric acid, HCl, and vinegar, acetic acid. So these are the examples of acids. You should never touch alcohol. It is very dangerous. It can burn your hand. And in the school, in the laboratory, we handle it with care. and we do not touch it with our bare hands. Always remember that. Some acids can be used as a food preservatives like vinegar or different types of other weak acids. So highlight their sour taste and bitter and the ability to react with metals. Include a pH scale to show that the acidic range is 0 to 6. So here is the reaction. HCl, when it is reacting with water, it produces a hydrogen ion and a chloride ion. So we have a hydrogen ion. That's why we can say that HCl is an acid. So here we have different types of acids that we can consume by consuming these fruits. Grapes, they contain tartaric acid. Grapes are sour. And I just explained it to you guys that acids have a sour taste. Tomatoes are also a little bit sour. So because they contain oxalic acid, like vinegar. Vinegar is acetic acid. Lemon, it is a citrus fruit, and it contains a citric acid. So ants, they also release an acid which is called formic acid. Apples, we have malic acid, and we have milk, we get lactic acid. So these were some of the examples of the acids that we usually consume from the food or from the natural sources. So what are bases? Substances that release hydroxide ions when dissolved in water. So whenever you add a base in water, it will give you this hydroxide ion, OH minus. So if you look at this equation as an example, so we have sodium hydroxide, NaOH. When it is reacting with water, it is producing sodium and it is producing hydroxide ion. So examples of bases such as sodium hydroxide and baking soda, sodium bicarbonate, these are examples of bases. Bitter taste and ability to neutralize acids include a pH scale to show the basic range is 8 to 14. So HCl and sodium hydroxide, so it is a neutralization reaction. Whenever the acid reacts with base, it will give us salt and water, and we call this a neutralization reaction. So these are the acids and bases. So and here is the pH scale. The pH scale starts from 0 and ends to up to 14 on 14. 7 is the middle number, it's the midpoint, and it is considered as neutral. So pure water is neither acid nor basic, it is neutral. And the pH of pure water will always be 7. And if you have something below 7, 6, 5, 4, 3, 2, 1, so these will be your acids. And if you go higher from 7, like 8, 9, 10, 11, 12, 13, 14, you have bases, right? Eggs contain bases, soaps, baking soda, ammonia, bleach, and oven cleaner. So the cleaning detergents that you use, they are also bases. So this was all about today's lecture. So if we have to summarize, we will see that we started from chemical reactions and combinations, and we talked about different types of chemical reactions. We talked about the displacement reaction. We talked about the decomposition reaction. We talked about the synthesis of a reaction, right? So so these were the different types of the chemical reaction that we discussed. And in adding it all up, we talked about the law of conservation of matter. We learned how to balance a chemical equation. And I told you guys that the left-hand side of the chemical reaction should be equal in charge and mass to the right-hand side in a balancing act, right? And hot and cold, we discussed exothermic and endothermic and exothermic reactions, chemical solutions, different types of solutions, and acid, bases, salts, and other anomalies. So thank you so much for joining me. If you have any questions, you can ask. Otherwise, this was all from my side. Thank you.
Thank you, Adnan. It's excellent class. Thank you, Facundo, for being here and defending for next class. Have a wonderful day, and Facundo.
Thank you
so
very much. Have a wonderful day.
Thank you.
Bye.
Bye.
Bye, Facundo.